Hello Prof, my name is Shiti and today I'll be presenting to you my CZ4171 course project. To start off, these are the things that I'll be going through today. So to introduce the main objective and process of this course project, the main purpose is to offload AI inference from an IoT device to the cloud, as IoT devices are often incapable of AI inference. Therefore, the AI inference that I have selected is image classification, and I'll be performing image classification on Singapore dollar notes. The process of performing money classification is as follows. First, the user can take a picture using his Android mobile device or to select an image from the Android device gallery. Then the image will be sent to the server, which has been developed in Python Flask. With the uploaded image, the prediction will be performed using the machine learning model deployed on the Flask server, which returns a result. Upon obtaining the result, it will be sent back to the Android device. Now, I'll be talking about the image classification model. So the first step of the project is to train our own model. For this, we'll be using Google Teachable Machine that helps in creating machine learning models quickly and easily. To train the model, I have taken around 600 images of each dollar note class, namely 50, 5, 10, and 2. The images are taken from different orientation and views, and the parameters used for training is shown here. Once the training is done, we can select under the hood to look at the graphs to determine how well the trained model is working. The graphs include accuracy per class, confusion matrix, accuracy per epoch, and loss per epoch. Based on the graph, the numbers have shown to be reasonable enough for the money classification application. Furthermore, we can check by uploading an image for the prediction to be shown. As you can see here, a $50 note is uploaded and classified correctly to be $50. Therefore, we can export the model to be in Keras format for it to be deployed in our server using the code given here. Next, I'll be talking about the Flask server development and machine learning model deployment. The server application used to deploy the Keras model is developed using Python Flask. As seen here, the Keras model is being uploaded to the file directory and declared here for usage. The node classes have been declared as well, which is used to return as a string response. The predict function here is essentially the code that was given previously from Google Teachable Machine. So in the server, all that's required to do is to use a post request to receive the file uploaded from the IoT device. Then, using the file name, it retrieves the path to perform a prediction which returns the prediction class. To test the server functionality, a test Python file has been created. So we will be running a test using the $10 note. Upon executing the test Python file, it can be seen that the server returns the predicted node class. So in short, the job of the server is to receive the image from the IoT device, to perform the prediction, and to return the prediction class through the response which will be displayed on the device. Lastly, I'll be talking about the Android application development. So this is the user interface of the Android device, which allows users to select image from the gallery or to take a picture using the camera to predict the node class by clicking on the predict button here. Therefore, there exists codes which calls for the on-click listener on the buttons to run functions to select image from the gallery or to launch the user's camera. With the image selected or taken, it will be converted to the image path using the getPathFromURI function. This image path will be used to upload the image to the Flask server. To upload the image to the Flask server, a retrofit library has been used, which manages the process of receiving, sending, and creating HTTP requests and responses. Therefore, it has been defined here in the Network Client Java class, where the base URL has been defined to be the Flask server IP address. After sending the image over to the server, it receives the response with the onResponse function, where it prints the node prediction class in the text view. Now that all three main parts of the project is done, I will be showing you the working application. So first, I'll be demonstrating the usage using an emulator on my computer. I will first select the image from the gallery and select Predict. It can be seen from the server, it returns the prediction class string, which will be returned to the Android device as a response and displayed on the text view. Similarly, for the camera taking function, I will select camera, where the camera will be launched, and I will take a picture of the $50 note. Click on OK. and select the Predict button. The prediction class will then be displayed on the text view. To demonstrate the usage of multiple users using the server at the same time, I will be using my personal Android device as well as the emulator. By clicking both the Predict button at the same time, the response will be displayed on the server, which will be sent over to the Android device to be displayed on the respective text view. Therefore, to conclude, based on the marking criteria, these are the following that satisfy the requirements. For the local inference, I have loaded the input from the gallery as well as through real-time input by using the camera. Secondly, the inference model can be inferred successfully using the Flask server where the results have been sent back to the Android device in real time. Lastly, I am able to run the Android application on the emulator as well as a physical device. Next, for the cloud inference, I have deployed a server program on my own computer, and I have ensured the communication between the server and the application to be working well that allows me to upload the image from the Android application to the server and show the prediction results from the server to the Android application. Lastly, for the advanced task, I have trained my own model by taking photos of the Singapore money notes, and training is done using Teachable Machine, which produces the Keras model. Also, I have demonstrated having multiple concurrent users using the server service simultaneously. And with that, I'll end my presentation. Thank you!